only then.
Thank you.
Okay, we'll get started, I guess. Okay, it's 10 o'clock and we got the projectors working. So this is the Icnrg meeting. So if you're looking for something else, this is the wrong room. Icnrg is the IETF research group for information-centric networking. You're most welcome. We should send out the blue sheets. Yep. Okay, and next slide. Okay. Okay, so this is the note well that applies also in the IETF. So make you familiar with it if you haven't done that before. And basically, yeah, we have to live with that one. You need to move to that part of the room if you want a better picture. Okay. Okay, that's the way to do it. So basically, it says if you're presenting or talking about something that you know there is IPR related to, you're sort of required to disclose that in a timely manner. So this is some basic information about this research group. We have a mailing list, we have a web page, and primarily we have the wiki page where we keep all the information about our meeting and upcoming events and all these things. I'm the chair. Sitting up here is me, Börje Jordman, then besides me is Dave Oran and Dirk Kutcher. Note taker, we have Chris Wood in front here, who's very kindly promised to do that. He will be assisted by Nilo Mitra over there when he's doing the presentations. The notes will be taken on this Etherpad, where you also all are welcome to participate in the note taking if you want to add something or correct something, especially if you're not well known and people get your name wrong when you talk. Please do that. And by that also, when you step up to the microphone, please state your name. Okay, this is today's agenda. It's, as you can see, pretty full, but we'll do the first half hopefully pretty quickly and then get into the more interesting things. So some general reporting from the chairs, then status of our documents, then we present a number of drafts, and we have some technical presentations also. And finally, we will have half an hour discussion regarding the proposed ICN BOF that was not accepted. So what the community want to do next and how to go, what next step there will be. So, and I should point out that this discussion is not something that is really part of Icnrg. It's rather we are giving time to the general community for this discussion on a possible ICN BOF or ICN working group. We don't have any control over that in any way or shape or form. Any comments to the agenda? Okay. Then before this meeting on Sunday, we had an full day interim meeting for the Icnrg. We had, I think, very good discussion on ID and locator separation, where Mark made an overview of what has been said and done both in the IP and ICN world regarding this, and we had a discussion that at least made me understand a bit better where we are and where we want to go. So you can look through the presentation and notes on that if you like. Other topics that we discussed included ideas on a downstream FIB, CDN pain points, an overview of what the CDM providers see as the problems today that Christopher Wood has made. We had some discussions on ICN security stuff. We also had a presentation from the Point project on how you can do IP over ICN and improve ICN performance or IP performance by doing that, they claimed. We discussed name resolution and name resolution servers and also ICN and IoT. So if anything of this is in your interest, please have a look at the presentations and the notes. All of this you can find from our wiki, where there are links to past meetings and all the material from them. There was Riot is an operating system for tiny devices, and their community had a meeting here in Berlin Friday, Saturday, preceding the IETF. It was an open meeting where anybody was invited, and you can find material on that also at their website, presentations and such. From an ICN perspective, we can note that Ralph Drums was invited to hold the keynote presentation about ICN and IoT. And we also on Saturday have one breakout group discussing ICN and IoT, and it was not only the regular ICN people, it was about half them and half Riot people that discussed this, and we had some very good discussions there as well.
So, by the way, the Riot guys made the slides available, so if you check out the web page for the Riot Summit, you will get them there.
Yeah. Then also earlier this summer, there was a Dag Stool seminar on information-centric networking and security. This was the fourth in the series of Dag Stool seminars we had on ICN. You can find it from...
You actually have to forward using the clicker, not using the laptop.
Oh, sorry. Stupid. So, where are we?
This is Riot, and this is Dag Stool.
Okay, so that was the Riot. Yeah, we should get it, make that one participate. Okay, so the Dag Stool seminar, we discussed things like transport privacy, trust and identities, name privacy, locators and identities, forward secret ICN IoT. So also, if you're interested in any of these things, these are the people that were at the seminar. If you know anybody of those, you can look them up and ask them about it. Yeah, regarding documents, we have a terminology document that we finally got started, and the first draft has been submitted. There has been much work, especially by Bastian. Dave also been involved here. So thanks everybody that contributed to this work. I think this will be very valuable. We have seen some initial comments on the mailing list. We're looking forward to a lot more and also more input to this document, because things will be a lot easier if we mean the same thing when we say the same things. So please participate and try to get this into a good document that can be the basis for our work. Yeah, at the Sunday meeting of the Icnrg, the pre-meeting, we also had some previews of some of the submitted conference papers that was accepted for the conference. The conference will be in Kyoto in September, and directly after that we will have an interim Icnrg meeting. We'll come back to that, but please note these dates in your calendar if you haven't done it already.
And there's going to be a workshop, I think, on the day before.
Okay.
Just so for your travel planning, I think there's going to be a workshop on the day before the conference on ICN and 5G.
Okay. So regarding the RG documents, we have 3 documents that actually are on its way out now, both the research challenges, the adaptive video streaming, and the evaluation and security consideration are all in the RFC editor's queue now, so you will see them soon coming out. There are no numbers, yeah. So what did you say the number was?
7933.
So the video will be 7933 if you want to be looking for it. Regarding the messages and semantics, I don't know if Mark or Chris want to step up and say a few words about the statuses of those documents.
We're going to have presentations.
Or we have presentations. Yeah, so we'll take that when we come to that. Okay, so we're back to the agenda. Yeah, so Mark is next for the object chunking thing then. It's the third main bullet.
I was assuming we were going in order.
We're doing in order. We've done 35 minutes already. So we're in pretty good shape so far.
Okay.
You have the slides?
No,
They've been uploaded.
yes, but I don't have them here, and then I can move them.
Oh,
Okay.
Oh, so did you, sorry, I didn't know that we were asking to do the presentation
Can you put them up?
on the semantics and messages.
It's looking to use.
You can come.
So, okay, all right.
If,
Okay.
do you need help?
we don't have a dongle here. It will do it.
So sorry, what are we doing for projecting here?
Anybody has an Macintosh dongle?
VGA dongle?
I have them now, but which one?
Oh, okay, we'll be okay.
Okay, so we'll do the messages, or sorry, do the semantics, the new PDF first.
Sorry for being a bit unprepared.
Okay.
Oh, no, we just got the slides. So.
Yeah, we just got the slides like 2 seconds ago, so.
Yeah.
Some of these ones.
Yeah. Okay.
Semantics first?
At least we have plenty of time.
Okay. Sorry for the confusion there. Yeah, I have a clicker.
All right.
Okay, so this is on the 03 update to the semantics document. And this is the URI is in the presentation that went out the mailing list about the diffs. So if you want to see the detailed diffs from the previous document to this, you can look there. The big changes in this document were we did more work to make sure that all behavior is in the semantics document and all IANA types are in the messages document. And there were some significant changes to get it in a format for requirements language. So, all the musts, shoulds, and so forth. So, we wanted to make this document more, it was very descriptive before and not so much prescriptive. So it's now prescriptive on the behavior of the protocol. I did not intend to change any meaning when it was rewritten, so hopefully all the meaning is the same, but it does deserve a good reread. So the new outline of the document it begins with the protocol overview, which is the remaining descriptive section that talks about how the protocol should operate without getting into like musts and shoulds and all that. And then it goes into a message grammar for an interest and a content object, and it defines all the fields, the meaning of the fields in those messages. And then it starts getting into actual behavior. So, how does the consumer behave? How does the producer behave? How does the forwarder behave? The bulk of the description is in the forwarder behavior. And then there's still sections on, what's a name, what are name segments. It talks about the cache control, what it means to hash an object, links, hash types, the validation section, the interest return message. So this is the new organization, and it was done so I can really lay things out and say you do this, 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 and this behavior-wise. Okay, so that's the presentation on this. If you haven't had a chance to read the document yet, I would suggest we do that, or I can field specific questions on it if you have those,
Right. So who has already read the latest version of semantics and messages?
Not very many.
Okay. So this needs more review, because it's basically telling implementers what to do, and we need feedback whether the document does that sufficiently. It'd be great if we can get a few more eyeballs for these documents. Okay.
Okay, yeah. I've received some email feedback on it, catching a few things. So, please read and send me feedback.
Can I jump in for a second? So I just want to, we're going to have a fairly substantial discussion towards the end of the meeting about what's the next steps for the technical work here. But if we're going to be able to progress things rapidly, we really need more eyes on the drafts that we have as Icnrg drafts of, actual proposals for working system. So I was a little uncomfortable with the number of hands that went up in terms of how many people had looked at this. If we're going to be able to move things forward, we really need, and this applies to the next draft and potentially a couple of others, we really need more eyes on these things. So let me cajole the crowd here that there's substantial technical material here and it needs substantial technical review. Thanks. Go on, Mark.
All right, this next one is on the related messages document. So this is the encoding of the semantics in a particular TLV format. This is a link to the diff from the previous document. So again, the big changes with the 03 was to try to get things, in shape for, moving them, beyond this group into review as experimental drafts. So we did a lot of work on getting an IANA section put together in what we hope is the right format, and also changes for requirements language just to make this much more clear. So we moved all the type assignments to the IANA section and only used symbolic names in the draft itself. And then we rewrote a few sentences here and there just to make the language fit, you know, may, should, must, etc. But again, hopefully there wasn't any change in meaning by doing that. And then we began work on a security section, though it's probably still a little bit light. So the IANA section right now follows these registries just because we have various, you know, this many independent code points. And I made a first swag at saying what sort of review and your material is needed to add a new code point. All of that is very open to discussion. I tried to make a good first guess at it, but I would, you know, invite anyone who cares about this to please talk with me and set me straight on it if needed. The general principle was, if it's, you know, like one of the really big types, like a packet type or a top level type, you know, you need, you know, a new spec on it, you know, or like RFC style spec, and otherwise you need expert review with a public specification. This is to get, you know, like a TLV allocated to you. There's still the vendor specific TLVs, which anyone can use with their vendor ID. And then there's still experimental types that anyone can just use. We've also been kicking around ways of numbering things slightly differently, so we use more of like an OID style number, so we don't have all of these different nested things, and maybe that would make more sense and reduce the number of registries some. Okay, so that was it. This was the big change, was reorganizing the types into IANA section.
Comments, questions? How many people have read this document? Yeah, about the same situation. All right, I won't repeat myself.
So next we had object chunking.
And you did not send me the slides?
Yeah, I did.
So we got you a dongle.
No, I don't have a slide deck for that.
Oh, okay, so I'm just going to talk about
But I can just talk about it.
Yeah, okay. All right, so the next sections are, so object chunking. This was a draft that was submitted like maybe a year or two ago and then never updated. And this draft describes how to use the name component called chunk number to take a file and split it up and, you know, do it in chunks. And it defines a name TLV that is the chunk number. It used to have a fairly long section about how to have a metadata file in parallel with your object that has stuff like, what's the total file length? What's the original file name? What's my block size? And all that stuff. We got rid of all of that because it's being superseded by the manifest specifications, the Flick manifest and so forth. So really the draft now is just, there's a name segment called chunk number. It begins at 0, increment by 1, and that you should keep using a fixed block size so someone could seek, you know, have you know, a chance of seeking, you know, through the file. So.
questions. I have one, which is, given that most applications data is going to be larger than a single packet.
Yes.
It seems like the chunking protocol is fairly fundamental in that you can't build an application without it. Is that true?
Well, so.
Or it's equivalent.
Yeah, you know, having the manifest specification helps a lot too, but
We haven't gotten there yet.
Yeah. Yes, true. That is not in a draft form yet. So yes, the chunking specification is fairly fundamental, and we think if a set of drafts is to move towards RFC status, the chunking would be one of those drafts that would move forward with it, because it is a fairly fundamental mechanism in packetizing the data.
Okay, so the reason I brought that up, how many people have looked at this? Backward reference to what I said before? Thank you.
All right, do you want a second on URI scheme?
URI scheme, yeah, so the URI scheme document, this was actually submitted back in April, but I don't think we got a chance to talk about it then. So the URI scheme for CCNX has been presented several times before. The idea is that because we have a TLV type for each name segment, we want to represent that type in the URI syntax. So you might have a URI that's like CCNX:/name equals foo/chunk equals 5. You know, and the purpose of this draft is to reserve and update the URI syntax such that this is unambiguous within the CCNX schema, but being fully compatible with the URI draft. There was an ambiguity because if you have an empty name, if you have a name segment without a type, so you don't say like name equals, there's an implicit type. This led to ambiguity if you have a 0-length name and it's just like CCNX:/. Is that an implicit type of name equals and a null value, or is that no first name segment? So we modified it so the first name segment in a URI must not be empty. So if you have CCNX:/, that is a name with no name segments versus a name with an empty first name segment. That was the diff from before. So you know, it's really an issue when you want to represent like the default route, which is a route with no name segments, versus a route that happens to have an empty first name segment. That's really the issue.
Right. So this is the set of protocol specifications that we are currently using in Icnrg.
Wait, we have one more.
And we have one more coming up on manifest that is say another increasingly important aspect. But so these are the ones we kind of have worked on so far. So manifest is still a bit say less mature than the others perhaps.
The manifest is still a work in progress.
All right.
But Chris will do that presentation. Yes. Okay. So yeah, please, feedback on any of this on the mailing list or in person would be great. Thank you.
Thank you, Mark. So let's hear about manifest now.
Okay, hi everyone. My name is Chris Wood from UCI Park, and I'm just going to be going over the updates to the Flick manifest specification. We originally presented this at the interim meeting in Paris in January. There was no discussion about it at Buenos Aires. So since then, there have been some changes kind of behind the scenes. If you've had a chance to read the draft, that's great. But if not, hopefully this should bring you up to speed. Sorry, this is just an overview of what I'm going to talk about. Just go over the basic design, the motivation for it, give you a description of the structure and the grammar for the manifest, and then talk briefly about the implementation at the end. So Flick is an acronym for File Like ICN Collection. Basically what that means is if you have a set of content objects in CCM, we want a way to represent them as a whole unit and easily or provide a way to fetch them easily from the consumer, or by the consumer rather. It's basically a data structure built on top of the Unix inode concept. That's to say it's like a hash table or index table into these different content object chunks. And we designed it with 3 primary goals in mind. The first one, we wanted to keep it very simple, and we think that is quite simple. We don't want to add anything to it and bloat it, because manifests, depending on who you talk to, have different meanings in different contexts. So this is truly supposed to be kind of a network layer manifest, not an application layer one, like something you would see in Dash. We wanted to be able to use a single signature to represent or encapsulate a series of content objects or a collection of content objects. And we wanted to aid the retrieval of nameless objects. That is a term we've been using for a while now. Basically, it's just a content object without a name field, not an empty name, just no name whatsoever. The current design has several different uses and features. For one thing, it supports seeking to arbitrary byte offsets within the larger piece of data. It allows you to encode chunks or segments of content objects equal size very easily. Like I said, it supports the retrieval and usage of nameless objects and nameless manifests. If you want to move entire manifest trees around, it allows us to easily kind of grow or extend a collection of content objects by, adding a new parent manifest that points to an old manifest tree, and then giving that a new name and a new signature. And it also allows support of variable size chunks. And by that, I mean, suppose you had a existing manifest tree in which all the chunks were of a particular size. You wanted to grow it for some reason by adding content objects that were chunked to a different size. It allows us to do that quite easily without having to rebuild the entire tree. So this is just the flick in a single picture. Here we have the root manifest, which contains an optional name like a content object would, that has one or more hash groups, each of which has optional metadata in it, including things like the overall data digest, which is basically the Merkle hash of all the application data underneath that tree, underneath that node in the manifest tree. A locator, which is something you would use to, or basically the name you would use when issuing interest for all the other chunks or children in the manifest tree, and some other things. And then it has inside a hash group just a bunch of pointers, or a pointer indicates the type of thing it points to, be it a data object that is a leaf of a manifest tree or another manifest tree, and an optional signature at the end. Typically, you would sign the root manifest and nothing else, because you're just fetching everything by digest once you have verified or fetched and verified the root manifest. And that's pretty much it. So the original grammar we started off with was as follows. So manifest was a special message type in CCNX. It had an optional name and these hash groups, like I've been saying, and the pointers are just hash digest, which were assumed to be SHA-256 digest. And we had a bunch of kind of different sets of metadata that we thought were useful. At first, we were kind of venturing into this area of speculative design. But after playing with them and actually implementing these things, we realized that some of these were kind of not necessary. At least right now, we don't want to add these pieces of metadata without having a good use case for them. So we simplified the design by stripping out kind of the unnecessary piece of metadata. So right now, it just contains a locator, an overall byte count, meaning the size of application data underneath a particular node in the manifest tree, and the overall data digest. And I have ellipses here to indicate that we're open to adding more pieces of metadata should there be a good cause or good reason for it. Another thing that we added was now a distinguished type of what I'm calling a block hash group, which kind of encapsulates the first design hash group, where you have every single pointer points to something of the same size, the same number of application bytes underneath it. But because seeking was kind of, you could do seeking in the old design, it was just kind of convoluted and not very clear. We brought back Nacho's suggestion of just having manifest hash groups where every single pointer has the size of data it points to, and therefore seeking is pretty easy. You have a pointer, you know how many bytes are underneath it, and you just seek based off that. So now we just have two options to support either one. If you have, for example, a big piece of data and you want to create a manifest tree from it, you want to chunk everything equally sized, you would just use the block hash group one, because it's very easy. You don't have to repeat the size value inside every single pointer. But if that's not the case, use the other one. The other thing we added was now the Pointers themselves are no longer just assumed to be SHA-256 hash values. We've adopted the hash agility scheme of the CCNX messages document, meaning that every single hash TLV indicates the type of hash and the length of the digest. And in the CCNX messages document, there's a predefined number of, or pre-allocated. We have clearly laid out what types of hash algorithms are allowed and what sizes of digests are allowed for each of those algorithms. So you can just take a beat there to get more information. So to give you an example, I think right now we just support SHA-256 and SHA-512, and then an application layer or an application-specific hash algorithm that's up to the applications that are free to use, or free to choose rather. Okay, and that just summarizes the changes. To give you an example in coding, this may be kind of a lot of information, but it basically summarizes the grammar. So you have inside of a packet, you have a fixed header at the top, you have a distinguished manifest message type, you have a name that's optional, and then you have hash groups which contain metadata and pointers or other types of block hash groups. And then to parse this thing and just go start fetching all the individual pieces of content objects, you would just walk it in order and do kind of a depth first traversal of the tree. Pretty simple. So implementation status, this is now fully supported in CCNX 1.0, and I'm currently working on the changes to make it supported in CCN Lite. That includes adding the hash agility implementation of the hash agility scheme in CCN Lite, because right now it's just, they're just SHA-256 things everywhere. And that is it.
Thank you, Chris.
Any questions?
Not just. Are we on? Are we on?
I can hear you.
Are we on? Uncomfortably close.
What are you doing?
Not just all Spark. I wanted to make a quick reminder that hopefully, in theory, the manifest doesn't have to be a tree, and it can be a DAG.
Yeah, that's correct.
And I know you mentioned tree a couple of times, so just wanted to
Sure.
remind people that it doesn't have to be a tree, it can be a DAG.
All right, thank you.
RG, let's.
Kevin Falsey, boy, you really have to get up here. Just a curious, I guess, and both for what you're doing, but also the generalization of it. The manifest in a Flute FDT, is it solve a different kind of problem than you are? Or do you compare versus that?
The manifest in the what?
A Flute FDT?
Flute FDT?
60, is it 6726?
I don't know.
Something
I
like
can't
that?
offer up a comparison about that. Maybe someone else here can, if they
Are
understand.
you
the design.
familiar with Flute?
I am not.
Ah.
So
Okay. So there's let's see, what's the quick version? So in one unidirectional multicast transfer out of IETF over, I don't know how many years it's been, in order to support encoding such as forward error correction, where you have different blocks that might be erasure coded or whatever, there was a whole effort used to distribute that. And one of the things you need is the manifest, right? And the manifest is all the different chunks, but in that case, there's another intermediate layer in the architecture that says this is the erasure coded or whatever other coding that's in there.
Okay.
And so the small question is, how does this relate to the FTT? And I just heard you don't know about it. But more generally, the question is, if the chunk distribution is FEC-based in some fashion, how do you accommodate that?
if the chunk distribution is fact-based?
Encoded.
Oh,
For whatever
encoded. Well, I guess if I understand the question correctly, I would just do that FEC encoding, I guess, before creating the manifest tree and then verify afterwards. That would be how I would accommodate it. Maybe I didn't understand the question correctly, but.
So maybe I can say a few words. So Flute was designed for like carousel-like distribution of in a multi-car or broadcast fashion for satellite communication, for example. And that application, I think, has slightly different requirements compared to what we are doing here with the manifest. So with the manifest, we want to have a random access possibility for consumers or applications, and want to have a like data structure. So the manifest itself is structured into individual items or tree-like structures. And I think the fruit manifest, they didn't need that really, because there you are basically depending on what the say unicast sender spits out, and then you're collecting over time. And here you want to be able to specifically traverse the tree and pick the chunk that you need for like a certain time frame or certain application.
Thank you. Yeah, Mark.
Hi, Mark Moscow. Yeah, we've done some internal work with naming things related to their eraser correction properties, but I don't think that there's a specific way in the current FLEC specification to identify the erasure correction properties that.
That is true. There's not.
That would relate different chunks. So.
That's right. That's correct. It has to be assumed at a higher layer.
So if I could add myself virtually to that queue, I mean, one of the things that is really different here from Flute and other things, which is that ICN attempts to make a unification of the properties of things when being transmitted and the properties of things when they're at rest. And what you want for loss erasure style protection, where you have to consider the at-rest loss of data in the same way as you think about the in-transmission loss of data. I think you wind up with a very different approach to how you erasure code things. So it's something we're thinking about, that if we need something for erasure coding data at rest within the ICN architecture, we need to design that. Whether it would affect the manifest design or not is, I think, open. And conversely, if we need something in the actual communication transport part of ICN in order to erasure code the actual transmission of individual objects or individual chunks, then we need to consider what we might need in that domain as well. So that's chair hat. That's my sort of technical view of the relationship between erasure coding considerations and any of this other work.
Okay, thank you. I had not considered that. We did not take that in consideration when designing this, but that's something we should be looking at. Thank you, Kat. Yeah.
Yeah, not just all Spark. Oh, sorry, I'm not a Spark anymore. I was going to say that there has been quite a bit of work done on the erasure code and FEC and ICN, not on the manifest side, but on transmission for wireless networks and for able to distribute queries over multiple things. That has changed over time, at least from a CCM perspective, since it doesn't do prefix match. So you have to know what you're requesting and just waiting for it when you don't get it. I think at least Cedric, which I see right here sitting, did some work on the FEC part or forms along those lines, and I believe Maya Gerla might have done something along those lines as well. Okay.
So I'll jump in again with chair hat off. So given the properties of transmission, the way we think about it in ICN, I would suspect that for the transmission part, network coding is probably a much better match than forward error correction. Just think about it for a while, and you might, I don't know, that's the conclusion I came to.
Yeah, but let's record that in the minutes. I think that's a good topic we should come back to later.
Yeah, definitely.
Other questions?
Okay. Thank you.
Wait a second. So, I mean, this has been around for some time, right? So
yeah.
We discussed it in phone calls and several meetings now. So the like messages and semantics, we kind of did the adoption as group work items.
Yeah.
So we would like to like assess the like feeling in the room, so what people think about moving this to a group document. So doesn't mean that we kind of finish the work on that, but that we kind of give up change control to the group and try to make an effort, to complete this, say in a like shorter time frame, perhaps.
That would be good, yeah. And we consider these to be like the chunking draft kind of fundamental to the architecture as a whole. Manifests
Right.
are a big part of it. So if
So we have to ask the one question first: who has actually read this document? Right. So
small number.
that may not put us in a good position to discuss adoption right now. Yeah, we really would like to urge you to have a closer look. So we can have that discussion on the main list. But I think the assessment from the people who are like working on this continuously, like in the phone calls that Parker hosting, we think it's relatively stable now.
Yeah. Yes.
Okay, so we will raise this question again on the main list. So, by the way, so what I just mentioned, so the documents that Mark talked about earlier and some manifest work that Chris talked about, these are progressed in, say, regular phone calls that Park is hosting, where they are open to the community. They are also announced on the Icnrg mail list. We also have minutes from that. So if you want to get involved in that, look for those invitations that Chris is sending around.
Yeah, they happen bi-weekly every other Wednesday. So.
Right.
Kostas Pedikousis, actually about Travel Pink. Based on that, and is there information on the wiki about that? Because I know that I'm getting the emails always after the thing has happened.
I send them out Monday prior to the meeting.
No, but you could add a section on the wiki of Icnrg with that
Fair point.
Oh, yeah, that would be a good idea.
because then, also random people that are not on the mailing list could see that there is activity happening.
Thank you. Good idea.
Yeah. With the minutes there as well, would that be appropriate to do?
On the wiki?
Yeah, well, we'd have to create like a subtree on the wiki, but
Okay. Yeah.
to put the minutes on. Right now, the minutes are just sent out email, so we don't have an archive. They're just in the Icnrg archive, right?
I have my own personal archive, but yeah, they're just.
They're in the Icnrg archive. Okay, that may be sufficient since people can find them just by searching the email archive. But
Yeah, whatever's easiest, really.
Here.
I think it's fine to put them on the wiki, on a separate wiki page for that. So if you're willing to move them there.
I can do that, yeah.
Yes, so that will be perfect.
Cool. Okay. Okay, thank you, everyone.
Thank you, Chris. Okay, so up to now we talked say about the core protocol specs that people are working on for CCNX and Icnrg. So we're now moving to a different say topic area, like talking about work that people are working on individual or bringing to the group. Before we start that, where are the blue sheets? Disappeared.
Blue sheets.
So
Who has not signed the blue sheet?
do you know where they are? There's one. Okay. Yeah. Please pass them
All
around.
right, please get the blue sheets to the people who have not signed, and then bring them back to the chairs.
Okay, Ravi, are you here? Yeah. So Ravi is going to present this status of a document that is discussing IoT, ICN considerations that has also been around for some time. But please explain the status.
Yeah, so this is supposed to be presented in Buenos Aires, but I couldn't, so I'm presenting these updates for this particular draft here. So the basic goal of this draft is to motivate, is basically to collect all the requirements from the IoT perspective and see why ICN is a good transport or a good network layer to realize IoT objectives. So people who are contributing are all active researchers in this particular topic. So just again to recap the draft history. So initially we had two drafts, two separate drafts, and then so point to you, I guess. Okay, so we had these two drafts. Then suggestion was to combine because there was an overlap in this draft. So we combined and basically came up with the first version of this draft. And this was presented in Yokohama. And then we had the architecture draft. This was even discussed in the last interim meeting on Sunday. Coming to this particular draft, this new version of the draft. So this basically sets the overall objective of this draft. So fundamentally, it identifies research challenges on realizing heterogeneous IoT services over ICN. So what we call is we call it as an unified ICN IoT platform. So understand IoT requirements to achieve a unified ICN IoT infrastructure. Again, discuss the suitability of ICN for IoT. This is considering that today's IoT platforms are pretty fragmented. Then you have ICN challenges. Then we basically identify all the ICN challenges to meet these IoT requirements. And because IoT itself is discussed in the context of multiple scenarios, we try to kind of summarize those IoT scenarios and those specific scenario-specific challenges in this particular part of the discussion. So this is the overall kind of the content of the draft. So we have the basic IoT motivation, then basically identifying what the IoT requirements are, discuss the state of the art. Then we say exactly what are the advantage of using ICN for IoT, the ICN challenges for IoT from different perspectives, and then the different scenario-specific discussions. So there was a request from the chairs to provide more comments on this draft, and we received a fair bit of comments. And so this new draft basically addresses those comments, right? So we had one of the comments. It was a contribution that was from one of the. It was a contribution that came on the mailing list. So it was primarily trying to have more details on self-configuration in network computing. So the basic details were related to decoupling sensing infrastructure from the application and easy reconfigurability of applications without updating the IoT firmware. So we took these contributions as is, and then there was another contribution on in-network computing in relation to the name function networking work. And so here, basic challenges on function naming, input parameters, protocol requirements, routings. These all basic contributions were. This particular contribution was taken in more or less the way it was contributed to us. Then we had another comment on basically stating we had a very kind of a broad comment on the core and the role working groups. So basically it was to correct those objectives of the core working group. And this fundamentally was in reference to the section 3.2 on where we discuss the state of the art solutions. So we added a paragraph for the core working group objectives and some details on CoAP and HTTPS candidate protocols M2 communication. And there was one comment on communication reliability. And here this was again a requirements part of the draft. So we said we need to investigate new routing structures to improve reliability in addition to what the RPL work from role is. There was another comment on including delay and jitter as resource constraints constraining satellite or space-based devices. So we modified section 2.3 and 2.13. So there are two comments separately. So in section 2.3, we added this particular, we addressed this, we included this kind of constraint. This again on the requirement side. And then we added a completely new section to on basically for IoT platform management itself. On basically, this was again adding a new requirement on the IoT requirement section. We had more comments on restructuring the section, so basically provide more clarity on this contextual communication section. So again, so this was addressed, and comments on basically on this is more on the scenario where we discussed, okay, transportation is one of the IoT use cases. Basically, comment was on not just limiting sensors for in-vehicle functions, but also for vehicle to infrastructure and so on and so forth. So we added a section, we modified section 6.4 for including those scenarios as well. So there was one more comment, but this was not, it is mostly editorial comment. This was after we came up with the new version of this draft. So, but this should be easy to address in the next revision. So next step, so this is primarily because all these comments were a result of the chair's request for the comments on this draft itself. So hopefully it will be adopted and then we can go for the next iteration.
Who's read this draft? Okay, we need wider participation here, right? Okay. So you're going to produce another iteration and we'll try to get discussion going on the mailing list so that we can assess the general level of interest among the RG. Is that the idea?
I could, because the one that's outstanding is pretty much editorial. I mean, it's not more technical kind of things that needs to be addressed, but yeah.
Okay, so I guess we'll start a conversation on the mailing list about what the level of interest in, continuing the work on this is, and whether we should try to move it forward for eventual publication out of the IRTF. Is that okay with folks? Yes? No? Okay. So just monitor the mailing list. Please weigh in, because silence for these kinds of things, it will be taken from the chairs as lack of interest as opposed to support. All right. Thank you.
Thanks.
Okay. So next we're going to have David Lake presenting on using low power wireless links for IoT and ICN. And where's the clicker? There. All right.
Okay, good morning. Before I start, a shameless plug for the IC5G workshop at ACM. There are two very important things happening on the 26th of September. The first is my wedding anniversary. The other one is spending a day at the IC5G workshop at ACM. I won't tell you which one is more important to me. I'll let my wife explain that. What I'd like to do is take you through a lab that we're building. This is a collaboration work that I'm doing at the University of Surrey, and some of the work that I've been doing at Cisco, to look at the applicability of IoT over ICN, specifically how this relates to low power wide area networks. Let me explain first of all, for those of you that don't know, what LPWA is. This is a technology which is being used quite extensively in IoT networks today, operating in the sub-gigahertz band. And sub-gigahertz, around about 868, 915, appears to be the sweet spot for IoT access in unlicensed spectrum. It's also starting to become the sweet spot in licensed spectrum as well, because of the propagation and penetration characteristics that we see at sub-1 gigahertz. You'll see a number of claims of coverage being made by the various organizations. The main technology that I'm dealing with is LoRa, long-range access systems, but you'll see anything from about 5 kilometers to up to about 40 or 50 kilometers of access capability from a single long-range device. This is a very low-power system. And the reason that they're able to achieve this is by a very clear management of the RF stack, so the ability to really control what's happening on the air interface. it's the transmit cycle that drains battery resources. Receive can go into a system where it's interrupted on a predictable schedule to go and look for new data coming back. So this is primarily a pooling mechanism where I'm pulling information back down from a single device. And the model is very similar across a number of different LPWA technologies that are out there. People like Sigfox, LoRa, Agenu, Talenza, they all tend to be operating the same system. The reason that this is happening is because we're looking at very low revenue rates for IoT devices, something around the dollar mark for IoT. So we need to be operating extremely efficient radio links. The amount of spectrum available at 868 and 915 is tiny. If you look at some of the marketing numbers around IoT, you know, we hear all these massive numbers about how many billion devices we're going to have. We're fitting them down into about 10 megahertz of spectrum at around 868 and 915 megahertz. So there is a disconnect and a mismatch between the number of devices that exist and how we actually operate this across the air interface. There isn't necessarily a requirement for IP on these devices either. So what we've found in a number of these IoT applications is that the air interface has followed the protocol specification on the device, which means that we see a highly optimized air interface for many of these applications, one that will push you towards extremely low payloads. So taking LoRa, which is the solution I'm playing around with, this is running at 915 megahertz with a maximum data payload of 11 bytes. Trying to fit anything other than I/O into that is very difficult to do. So we need to get to a situation where we're able to compress the information and handle that across the air interface quite successfully. Excuse me, I'm suffering with Berlin hay fever, would you believe? The other access types that we can start to consider outside of the unlicensed spectrum fall into 3GPP domain, into narrowband IoT. If you've been following any of the work happening in LTE, there are two new specifications, LTE M1 and LTE M2, both of which look to refarm PRBs, the physical resource blocks, the 180 kilohertz OFDM sessions that make up my LTE structure. And they will refarm those into very low data rates portions of spectrum, which means that I can overlay an IoT-capable network on top of an existing LTE network without breaking my synchronization between PRBs. And that's a good thing because that allows me to upgrade existing LTE networks, potentially with a software upgrade to support IoT. That means that I can start to have licensed and unlicensed IoT access that starts to look quite similar. So my LPWA is running on unlicensed, my NB-IoT is running on licensed. The common factor here is that I'm dealing with very low data rates and very small payloads. Coming back to LPWA, all of these systems use an Aloha scheme. So we're down at a potential loss, which could be quite high. You could be down at 90% packet loss or service loss on some of these systems. This is a real challenge because we can't afford to simply retransmit on demand. That last mile link is really where we need to manage the devices. Looking at the devices themselves, these are very, very small devices, very small CPU, very small memory requirements. And again, anything that I do on the processor, anything that I do to read in and out of memory uses battery power, and battery power for a parking sensor that I'm going to bury in the road and leave there for 20 years. That's what matters. I cannot go back and revisit some of these devices. For example, in-building sensors are often specified 5 to 10 years before the building is put up. So the question then came up of, well, what techniques could we use to try and dedupe sessions across that last mile? And the obvious answer that I saw was ICN, specifically NDN in this lab, would help us. And could we actually use some kind of interworking system here to provide a mix between LPWA techniques and the world of NDN to give me that mapping between the native names that exist within my IoT world and the ability to access the stack from a transport protocol. So how does this work in practice? Well, the lab built consists of a number of LoRa access points. And I have two planes. I have my control plane, which resides within the LoRa domain. I'm not actually changing that in any way. That still talks at the top here to my application enablement platform. This does all my security encryption for my air interface. So I'm not actually looking to integrate at this point the ICN level into the application enablement into the LoRa side of this connection. So this stays completely as an overlay network. My applications will then go and ask for information from that sensor, and they'll refer to that by the name that's known within the NDN device. And what we're finding is that the mapping of sensor identity to ICN names is actually very useful here. I can have a dual application here that not only gives me mapping for my LoRa devices, but it also allows me to have a mapping system between how I know the application, for example, a temperature sensor within a room, and an NDN name that I've been able to implement within my NDN structure. So that allows me to start connecting these two worlds together. The data connection then is made through an interworking function here, which could be then talking to an application, a consuming application, which is running existing IP. So my interworking function there would be taking my IP sessions which are requesting that sensor, realizing that that exists both within the IoT LoRa domain and the NDN domain, and providing access to those devices. And this is essentially what we have running in the lab at the moment. The other really interesting part that we can start to look at with NDN is to try and meet this demand to dedupe and make sure that we're using this last mile connection in a minimum state. So if I have some context associated with this moat, with this sensor sitting out here, I might know that it's in a slow moving temperature sensing environment. For example, I might know that the temperature takes a certain amount of time to rise within this room. If I have a consuming application here that's asking for that data, and then another consuming application that's asking for that data 5 seconds later, I can make a decision that the chances are that that data hasn't changed materially in that 5 second time. Actually asking for that data back across the last mile link would be very expensive in terms of RF link capacity. So it would make sense then to take use of the caching capabilities within the NDN network and reply to this application from within the NDN structure rather than creating more air interface and using more battery power. So we're exercising some freshness indicators within this as well to see, well, how can I determine what my longevity of information is on this side, and at what point do I need to recreate a session across this side? That then has some interesting knock-on effects, because this is a broadcast network on this side. So I may not have a single air interface connecting to this sensor. I may have 2, I may have 3. The question then comes up of what else can I do within this NDN structure that maybe understands some of the metadata that's being passed back across my IoT network, such as received signal strength, bit error rate, or potentially a policy. I may decide that these devices actually only warrant a low class of access. If that's the case, I only address them through one air interface. I may have other devices on here that demand a higher policy in terms of IoT application. And I can start to build structures within this network that allow me to determine the best path to reach this device when it's appropriate to reach this device. I could take that further as well and start looking at the data structure itself. For example, in a temperature sensing environment, I might decide that, yes, I only access this every 10, 15 minutes, provided there's no rapid change in information. If there were to be a rapid change in information at the sensor, maybe I could exert a policy at that point which caused that data to be driven directly. So this then becomes an override system which we can then use in here. So the idea of overlaying some kind of dynamic policy within this NDN structure as well is also something that we're looking at. How does this lab actually look in practice? Well, you're looking inside the back of my garage here at the moment. This is what we have running, I have running at home. We have a copy of this running in the lab. And you'll notice there's a whole set of antennae on here. And there are 4 LoRa access points running in here to a single sensor. This sensor is an SDK, which is available from, a development kit available from IMST. The actual sensor is this device here. It's about 20 mils, and it includes a Cortex a CPU on board there. Quite a powerful device, but it goes into a deep sleep mode between receive cycles. So you do have to get to a point where you manage the I/O of this very, very carefully. We have some issues. We need to work out what this mapping is between LoRa IDs and the network names and the network addresses. So actually designing and building the interworking function, designing the mapping between an ICN data structure and a LoRa data structure is very important. We also need to think about how to register these devices to the edge of the network. At the moment, we have some scripts that essentially hotwire fibs and put names, associate names with ICN context, and distribute that in a manual method across the structure. The broadcast nature of LoRa and LPWA is also quite difficult to handle. We need to understand data context and data concurrency. If I'm asking for an information flow across 2 RF paths, where do I take that decision about which RF path has the information that I need? And we also need to think about the polling mechanism. This is a wake up, request data, pull data back. It's not an end-to-end communication in the kind of model that we're used to. We haven't really started to address security. I've kept the 2 security domains completely separate. My OTA environment on LoRa uses the security built into LoRa. My NDN side doesn't use anything at the moment. So we need to think about that. We need to think about a concurrent data presentation across the 2 of this. Where do I want to go with this? Well, we have a core network built at the moment. I have a willing student over the summer that is going to build up on the AAU Banana Pi based NDN stack. So we have a stack of about 25 NDN enabled Banana Pis ready to go. We're going to start putting some access points on that. I'd like to introduce other RF technologies as well. So the whole goal of this is to provide a single interface from an IoT application point of view across multiple air interfaces. The question is, could we use NDN substrate as a method for providing independent air access, irrespective of whether this is LoRa, Sigfox, NB-IoT, Wi-Fi, whatever? What is the applicability? So I'm looking to introduce some NB-IoT air interfaces to this and anything else that we can throw in there. So the conclusion is that ICN actually seems to be very well suited to this IoT application. It was actually quite simple to build an initial lab and to have this working. We need to look at the security model because that also could be appropriate for some of these air interfaces as well. And this capability of providing deduplication by local caching is very useful. We're showing quite a reduction in air interface over a traditional IP network in this instance. We need to solve some of the multicast issues, and we'd like to collaborate with other people that are doing similar things. Any questions? And a shameless plug again for the ICN 5G as well.
Hi, Peter Ashford-Smith, Huawei. A couple of quick questions. I think it was your second slide. You mentioned narrowband IoT.
Yes.
And you talked about encumbered by, what does it say? The EPC. Did you want to make a couple of comments? I was wondering if you had some thoughts on that.
Yes. So the narrowband IoT at the moment follows a standard LTE EPC type of environment. So I have a solution in EPC where everything would be anchored on the P gateway at the center of the network. The question is, does this now, I know that we're looking at methods of virtualizing EPC, bringing these components down to the edge. And obviously 5G also talks about mobile edge computing where I'm able to place devices within either the eNode B area or an aggregation point at S gateway. So this is where I say that we possibly need to look at the architectural structure of EPC and see how that would become appropriate. At that point, could I start saying, well, I have NB-IoT traffic that's treated in my 5G network slice in a totally different architectural model to that which I currently have on BS gateway, P gateway type of environment in LTE.
Okay. If you have any specific thoughts about how that would happen?
I think the way to do that is by virtualization and distribution of the EPC components. The problem that we then get into is how do we actually classify traffic as it enters the edge of the network and is switched into an appropriate area. And that's really about traffic classification, potentially beyond that which we can currently do by APN within LTE. Maybe we need to start looking deeper in that traffic. For example, in this environment, I can see instances where we would have non-IP traffic. At that point, could I look at the fact that I have non-IP traffic and use that to switch into an EPC or into a MEC environment, which gives me my IoT application locally?
So almost a non-IP EPC for IoT.
Well, we already have the ability to support non-IP traffic in release 13 EPC. The question then is, how do we use it? So I think having got to the point where we have that standard, what we now need to do is think about the architecture that supports that.
Okay. One other quick question. On your last slide, I think you mentioned incorporating narrowband
Yes.
IoT into a proof of concept. Is there an open source project on the way?
There is an open source project. There's a organization called Eurocom who are building an open source LTE, or have been building open source LTE.
Are they doing narrowband IoT as well?
They are not building out narrowband IoT at the moment. The interesting part for me would be when they do start to build that, because then we can start to build software-defined radios with open source, the open source EPC components and distributing that into the network. Yes.
Their open LTE, their open source LTE works very well. I've got it.
It does.
Lab. It's
Yes.
awesome.
Yes.
Thank you.
Hi, Ravi from Huawei. So I had a question on what you use for names in the Indian part of the network. You said you use identities of the smart things itself, but the identities are supposed to be host identities. They're not really content identities.
Correct. So at the moment, we're using simple names that we've used around the lab simply to identify sensors. Yes, this is we need to get to a point, and the draft, and I'm guilty of not having read the IoT draft, apologies, but I think that's an interesting area where we could start looking at, is there a naming convention that we could and should apply across IoT devices in this case?
So my one point is that, because when you talk about NDN, CCN and all, they pretty much only consider the content as the principal, not the host or services.
Yes.
So, probably architecturally, you need to differentiate these things.
Yes.
The other thing, when we discussed in the interim meeting, we have a draft on this, is also about the push. It's not efficient to do IoT kind of systems using a pull model.
Yes.
Right. And because we said you need things like multicasting and things like that.
Yeah.
And basically, even as pub-sub it's a very integral part of an IoT system.
Absolutely.
So, are there any considerations on?
Yeah, so that's essentially why we've left the LoRa structure in place, because this uses the pull system. And then essentially we're having to go back and make requests of that. The freshness helps us to understand that the data has been pulled from there. It is not ideal. We need to think more about that model and the difference in that model. So yes, this has been a challenge to actually get to that point.
And do you think you could avoid the protocol bridges? Because we had a proposal saying we could actually potentially have a single protocol end to end.
I'd love to avoid the protocol. The idea of building the interworking function is difficult. It was a means to an end. Again, if we can get to a point where we have that, the agreement on an IoT structure within ICN, yes, we can start to take components away from this. And I'd be very happy, because the interworking function was the most complex piece to build in all this.
Thank you.
Hold on for a second. Are there any other comments or questions regarding naming structure before we move on with new questions? Okay, then please go ahead.
So I guess it's maybe a question if you could just elaborate a little bit again on the interface between the two portions of the system as I see it, I guess. Because it seems to me that these air interfaces, in many cases, are kind of almost designed more to allow push traffic in the
Yes, they
uplink. And in some cases, it would be even asynchronous triggered kind of information. So, you know, a temperature overload or threshold being passed. And so you get this asynchronous and very costly to be listening on the downlink with significant or low frequency kind of cycle. So, but now on the back end side, you essentially have this pull model from the consumers. And it almost seems like you could just do this at the application layer where things are getting pushed up into a database and then people request the stuff from the database. Is it more or less like that?
So part of it is one of the other reasons to think about this from a goal of 5G is to say, well, 5G has this idea of being the ability to operate across multiple air interfaces, which are appropriate for the style of traffic. So this push model, the difference in the model could work well in that I'm sending regular information through a system that doesn't actually mind that there's no constant communication channel. And that would potentially use this kind of environment or a similar unlicensed environment. We probably need to get to a stage where if a device has multiple air interfaces, it not only understands the context of the air of the data, it understands the capabilities associated with the air interface. So for example, I may have a GPRS link as well as my LoRa link. And if I have, such as you say, if I have an alarm condition, I would go and use a defined GPRS link or a high value QCI on LTE, because I know that that has a certain SLA associated with it. That implies some kind of coordination between the air interfaces and the data, which then gets us back to the naming convention, because what I don't want is two naming conventions running over different substrates. I want a single naming convention that's able to understand the capabilities of each of these. And I know that we weren't going back over the naming discussion. So this is the whole area that we're thinking about. And if you look at air interfaces used in 5G, in IoT at the moment, I've counted 39 different air interfaces, each of which have a different capability. If we can build this into some kind of discussion about available SLAs and available capabilities, then yes, we can start to say, okay, my pull data goes this way, my push data goes this way, my urgent data goes this way. It's an open question. In my mind.
Just quick it up. So we have a really important discussion coming up later about next steps. So I'd like to cut the lines with the people who
I
are
just
currently
wanted
sending.
to fix my mistake of not mentioning my name, Vince Park.
Okay, thank you.
My question is very quick. So Emmanuel Bocelli, INRIA. This is very interesting work. Thanks for bringing it up, and looking forward to.
Can you speak up a little bit?
Yeah, very interesting work. Thank you for bringing it up and describing it here. Just a very technical question, quick. So you said you plan to use CCN Lite down on the modes. That's great.
Eventually.
But doesn't really run bare metal. What do you plan to use below? Is it Riot like other people do, or is it something else?
So some of this work predates my knowledge of Riot, unfortunately. So I spent a huge amount of time trying to compile CCN Lite down onto devices that fundamentally didn't want to run CCN Lite. So I think that's another area that we could look at. At the moment, yes, we've compiled CCN Lite down onto some of the small devices. Whether this is useful or not, I'm not entirely sure, because we have the interworking function doing much of this. The next stage is to move this to a pure CCN, NDN type of environment where the end devices themselves would be running that. And I think at that point, Riot is the way that we would go. Again, I need to look at what our next steps are and who we would work with to do that. Work in progress.
Yeah, we have some experience with that, so maybe we can take this
yes,
offline.
Please.
Okay, thank you very much, David. So it's really super interesting. So this is exactly the type of work we'd like to see more in Icnrg. So it's really useful to hear about experience from experiments, suggestions, maybe how ICN or certain implementations should evolve. That really brings us forward. So thank you very much again. Coming up, we have another presentation on IoT. So Alex is going to talk about new NDN work on that topic. Give me a second to bring it up. Oh, if you want to.
Get that out of your way.
Okay, so this is kind of continuation of what David mentioned, but in more practical advertisement or sense. So we did the initial prototype implementation of NDN stack on Riot, and this is just showing that it is there, so you can start experimenting, contributing, and we're happy to do all the merges. Just small kind of repetition, just a slightly different angle on the things. So NDN, ICN in general have an edge in IoT, meaning that the semantics that IoT have can be really moved to the networking level. So the network can assist in different things. And one thing that I kind of reference here is our recent paper where we say the semantics, like the thing like of the Internet of Things is not the device itself, but rather the thing, the temperature, the kind of air, the measure of the soil, pH of the soil. So all of those things can be done purely in ICN somewhere. And of course, we need some global actual implementation to play with it and do things. So, okay, I guess I'll skip this slide, but just a general statement that on the edge of the IoT right now, we have very small devices that kind of constrain battery power. They're very constrained. This may change in the future, like if for some reason technology will require a lot of processing power, or our battery will be better. But as of right now, we have very constrained things, and RiotOS is a very good candidate for the operating system, or lightweight operating system for those devices. And there are a few candidates just in case you want to look for alternative. And then Riot is kind of our attempt to just bring NDN stack on this limited platform. We try to optimize this implementation, like just specifically for the Riot. Just keep things simple, but working. It implements a basic NDN packet forwarding. There is a data-centric security support, and I will show just a few basic numbers about that. There's a kind of very basic application API that you can use to build your NDN-like application. But again, this is just the beginning of the work. There will be, we hope, your participation in taking this code, playing with the code, giving us some feedback about the code so we can, or actually contributing to the code. So all the links there, everything, I hope it's working. Just a small overview of the overall architecture. So on Riot, everything is represented. There's no kernel per se, but there are like different modules represented by threads. And NDN thread is basically NDN represented as this NDN Riot module thread plus whatever the application you will be designing and playing with as a thread. And within those threads, there's a intra-process communication that just getting in the packets from the network stack and pushing packets to the network stack. Just a few, we try to do some optimization for the memory. As I said, there is some hacks, or not hacks, some implementation about the shared memory. Attempt for the shared memory. We did implementation for the data-centric security. So one of them is ECDSA. So we can actually assign this data packet. Not fast as of right now, but it is possible to do. If in some cases, when you can afford to do symmetric mechanism, you can end up using HMAC, which runs pretty fast or reasonable speed. Packet forwarding, there are all the basic data structures that necessary for the packet forwarding. there's simplified implementation of all of those, but semantically everything is preserved. Again, there's a lot of work in progress, and we hope participation from you and as well comments from you. For the level 2 communication, it runs basically on 802.15.4, like on a native level, so there's no additional layers on top. For the debugging purposes, there's also Ethernet support, so if it runs on a native platform. We also implemented a very simple version of hop-by-hop fragmentation, so it would be either link adaptation or something like that. You can check the details in a paper in more or in a code, or we can talk. Okay, I'll skip this one, but this is just an overall picture of how the application can be designed for the right. So if you, I'll skip that. Just a few numbers come in this slide. I'm not going to talk in detail about this slide, but rather just highlight that with the current implementation, you can put the NDN stack or NDN application within very, very constrained platform. And this is just highlight how much memory, what is the memory requirement for very basic application, which kind of represent some sensory application that generate data as in response to requests, or just generated data and response to request as the response comes. Yes.
One question, nice numbers. What size of cache do you have for these numbers? I'm talking about like the content store or equivalent.
Yeah, so the cache size is kind of, as of right now in the code, is configurable at the compile time, and I think it was like 25K or something. I forgot the exact number, but small.
Okay, yeah, thanks. It was Emmanuel Bachel, Icnrg.
And just a few now, like performance parameters with mention 2 boards with 2 experiments that we run. We run like our local experiment with the SAM R21X Pro board, and we also use the IoT lab. So this is very great resource that you can actually use the existing testbed deployment to run the experiments. So I guess the only thing that I want to highlight here is ECDSA, unfortunately, is yet slow. I hope it can be improved with additional hardware support if it's necessary. But again, it is still possible to do these operations, given these IoT applications, and not necessarily these high performance things. Like if it's a sensor, it may produce a sample in a few seconds, in a few minutes, and you can actually sign that sample on that sensor, so it kind of preserves the data-centric security properties. And with this parameter, with this kind of table here, the idea is that the performance is comparable to the IP stack. So there's no more for the bare bone communication. If you just interest data communication without additional caching of anything, everything will be fast. But adding the cache gives you more benefits.
Quick clarification question. You're saying it's not better than IP?
In the equivalent scenario, so if we remove the caching, it would be about the same. I mean, how it can be different if the packet has to go there and go back. So this was just basic measurement for our RTT, just to figure out whether we introduce a lot of overhead, like in our NDN, or there is no major overhead.
Well,
for the data structure.
I think this is kind of a comparing orange with apple. When you say the same or not the same, because what is measured is the round trip. However, there's a question of what you get after this round trip. In IP, you get the IP packet. Then you have to go through a few ladders in order to get to something that application understands. In NDN, you directly get a piece of named data.
Okay.
So I argue this with Alex, but he's more on the mechanical side to say, oh, there's one round trip, so that's the number.
Perhaps.
Hi, Ralph Drums. I would actually make the argument somewhat differently from the way Alicia did. I wouldn't expect tremendous differences in the round trip times no matter what. I mean, no matter what you're doing, it's you know, a round trip time. What I would compare is the number of messages for a particular application, the size of the two stacks. I'd be interested to see the size.
So this is definitely a much better comparison than what we did so far.
Okay, and there was I know the other one, the background control traffic. Do you save anything in using NDN over the generic or the available full IPv6 suites for IoT deployments like Zigbee IP or Wi-Fi FAN or Thread in terms of the background control traffic? Is it possible to do things without having to have the kind of ongoing update for address management, for routing, et cetera, et cetera? I think those would all be really useful things. And I think that's where we're really going to see the difference.
I see. Yeah. So this is definitely correct, and this is the next step. So this is just the first step that we just finished, and we would try to bring this work for everybody, to get these comments and kind of move forward very quickly. Yeah.
Virtually, Inria. Again, nice work, and looking forward to next steps on this. Just a pointer, we had a paper in ICN in 2014 that went a little bit further. It didn't go all the way, but it went a little bit further, and maybe you can look at that. It's trying to compare the IP stack with NDN. On similar types of device on IoT Lab, and looking at different types of aspects of how many messages, the size of the stacks, and everything. So it went a little bit further, but so I can send a pointer if you want.
Okay, thanks. Okay, so that's basically it. So we have a few works, kind of ideas in progress, and we hope we can get the support from you. I have put this additional slide, but I'm not going to talk. You can download and look at it.
Thank you, Alex. Are there further questions?
Thank you.
1 second to contact us.
Hi, Oliver Hahn, Inria. Very nice work. Very much looking forward to play with it. I have one comment additional to what Emmanuel just said. There is this IoT Lab testbed with over 3,000 nodes. And so right now we have 2 different NDN implementations in Riot, and it's supported on the testbed. So it's a very good and helpful platform to do IoT, ICN experiments. And I have one question looking at your code. Usually in IoT you have only one network interface, or in most cases you have only one network interface. If I saw it correctly, the mapping from faces to the mapping of faces is done to a network interface currently. Have you considered doing it differently, or what's your idea of how to map faces to anything else? Or
okay, we probably can talk about this offline. So there are a few ideas of things that are really in progress. Okay, in that respect.
Thanks.
Okay, thanks again. Okay, blue sheets we have in
anyone that came into the room? Put your hand up if you've not yet signed the blue sheet.
Okay, now, so we'd like to use the rest of the meeting to discuss next steps for ICN, the specification work we are doing. So, as you might have seen, there is like increasing interest from different parties to do more with ICN, like do more experiments, move ICN closer to deployment. And you may have been aware that there was a proposal for an ICN working group for this meeting. So that didn't get approved for several reasons. Also, scheduling was really tough this time. But there were also some questions raised. So in the review process of that proposal, so questions regarding the maturity of the specification work, like whether the scope is actually well understood or well defined. Questions as to like the level of consensus, like in the larger community, to support that specific proposal. The role of security, privacy in that discussion, but also like, IPR concerns or requests for clarification on that matter. And so we'd like to use this meeting today to discuss a little bit about that. So, so is there something we can do as next steps? So what is the goal we actually want to pursue, and yeah, how would we actually do it? As a clarification, so working group formation or like BOF proposal or anything, that's nothing that like the Icnrg chairs are directing or requesting or anything. So I mean, anyone can come up with a proposal for like working group BOFs. So we would just like to sponsor this discussion in this meeting, so this face-to-face time here. So that's why we are discussing it now. It's not that we are trying to, as chairs, create a working group or anything. So please understand that. So the concerns regarding the consensus in the community, say about the ICN approach specification work so far. So you know, we have been working on the documents that Mark presented in the group here. So TCNX specs. So when we do that, that normally means that a author or a team of authors are like advancing the specification on behalf of the group. So the Icnrg takes over change control. So every one of you is entitled to provide feedback, comments, and discuss with the authors about useful additions or changes to those documents. As we mentioned earlier, so the technical work and discussion has been done in additional phone meetings, so they have been announced. And again, we will make this also available on the wiki. Having said that, doing this does not exclude other people proposing specifications and also proposing group work items for that, right? So that's, we didn't say, okay, this is exclusively the set of specification we are working on here. It's just that we haven't seen any other contributions so far. But, well, as we all know, so there are different projects, architectures, and implementations, so mainly the CCNX and NDN. And so the like feedback that we got from people working or doing research in that space was it's somehow irritating, so like especially for people who are not really working in those projects. So what is actually ICN? It doesn't be a healthy signal to the community industry if we can't really say agree on an approach or say and at least explain why there are differences. And so during like last days and weeks, people got together. So these like CCNX team and the NDN team started some discussion to figure out, is there some way like in a collaborative fashion to overcome this situation? So can we maybe do something better that would also help us, say, in the longer term to maybe create specifications, experimental, potentially standards in the future. And so this is, well, so maybe convergence effort is not the best title, but as I said, and those teams had first discussions and intensive discussions during this week. And the good news is that there seems to be some agreement and understanding about useful next steps. So the proposal that came out and that was developed by those discussions was it would be really, really good as a first step to understand and also document the differences of the current designs. So not only in terms of like protocol fields, mechanisms, and so on, but also really what are the technical motivations and also what are the semantic consequences for these differences. And yeah, there seems to be good support to really do this and say provide a better understanding for the community and also for, say, helping potential upcoming work on, say, a unified set of specifications. So that is what I'm referring to when I say resolving differences. So what was agreed upon was to work on a set of, so taking the analysis as a basis to work on a set of specifications that provide an initial set of specifications that would be acceptable for the different teams, so mainly Icnrg and NDN teams, but also people who are working with those implementations and architectures. And that doesn't have to say that, and doesn't have to mean that this would be, say, the fixed set of specifications. So it has been understood that there needs to be room for evolving things, also for learning from experiments and maybe extending or features or other elements of those specifications. So what we kind of came up with as an intended outcome was it would be really good if we first had a set of, say, consistent experimental RFCs that represent the community at large consensus on like one combined ICN, so NDN CCNX design. And like for like advancing the state of the community / industry, it's maybe even not that important to have like standards document right now. Just a experimental set of RFCs would already be useful because that would enable people to take that to further experiments, which we actually need to do, but work with the technology maybe in initial deployments, for example. So that was what has been discussed and agreed by those teams during the last days. Before I move on, are there any questions for clarification on this?
You have one more slide.
I know. Okay, so hold your questions to the end then. So this is basically what we would like to do. And this is say some thoughts about how that could be done. So for documenting these differences, doing this comparison and analysis work, so we as co-chairs, but also the people who were involved, thought could be a good Icnrg activity. So we have the expertise here. I think we have the teams here. So that could, for example, be done by a focus team that like maybe similar to the CCNX specification work, kind of meets frequently, maybe in phone calls, physical meetings, and so on, and reports and discusses the outcome with the Icnrg at large. So there shouldn't be like a secret activity, it would be a design team that would work for the Icnrg. For the second thing, the specification effort, I mean, there are different ways how to do that. So it's probably certainly feasible to just continue doing that work in Icnrg. So as the analysis work becomes more mature. We probably know also a little bit, so what is useful to have in this set of unified specification. But it's also possible that people think, oh, this is really urgent and for like a standards activity. And you could also think about doing this in a working group and propose above for that. So that, of course, should really be based on a good understanding of scope and applicability. So these are the like two options that we currently see as next step for the specification work. And so this is all I had. So basically, the idea was to update you on say what has been discussed so far, what happened with the BOF discussion, and now yeah, let's discuss this. And we would like to hear your opinions on these ideas.
So basically, open mic at this point.
Yes, Kostas.
Kostas Pedikousis, Travelpink. So I was skimming through the IETF journal, and I came across an article that talked about I think, operations area working group that was spawned with a single target to make a single RFC. And if I remember right reading the article, it basically went along the lines that, hey, we can be actually fast in the IETF, you know, from chartering to RFC publication, let's say 15 months. So I understand some of the background, perhaps not everybody, and I definitely don't understand all of the background. But to me, this is a little bit, it appears as such a heavy process, which may give the wrong signal outside of the community of why is it so difficult to do the working group. And it could be that, you know, Icnrg creates not one working group like DTN did after a decade or so, but we create one, we do one thing, and that's very focused, and then we move on to another thing, perhaps. So it doesn't have to be a DTN-like kind of development, you know, until everything becomes super mature in 15 years. We may, you know, there is a boat or a train to catch in the next few years, and probably Icnrg, you know, aficionados would be interested in being on that boat. So that's all.
Okay. Is there any immediate response to Kostas' point?
Okay.
So I'll respond with my chair hat off here for a second. I think one of the things that in a sort of deep way divides work in the Icnrg and the IETF is that the IETF tries to drive toward standardization of a single solution for any given set of problems. So when work moves into the IETF in an area, new area, be it DTN, ICN, anything else, there is, generally speaking, sometimes we get multiple solutions out of the IETF, but generally it's thought to be better if you get a single solution. The Icnrg is now open to many different ways to do ICN, will continue to be open to many different ways to do ICN. And, you know, if some of this, it seems to be, you know, combining to something that's mature and will get wide acceptance, I think that's a great thing. But I want to make sure people understand that the Icnrg does not somehow at that point become closed to new ideas and alternative ways to approach problems in the ICN space.
I understand that, but just to, you know, cross-reference the closing plenary yesterday, there's more than one way to do tunneling. And if you see ICN as tunneling, then maybe you can do IP in UDP in IP in MPLS I'm just saying. Okay. But I understand yeah, maybe let me.
The fact that the IETF often comes up with multiple ways of doing things is a consequence of reality, yes. Yeah. And that's not generally what the IETF strives for as a goal.
Let me quickly respond to that. So what I think was like felt by the teams that were discussing this was Sure, there are some theory, there are different ways to do things, but we also had the feeling that there are differences that may be really fundamental, but others are actually not. So others may just be something that has evolved over time and it's maybe not more on the syntax mechanism level. And we would really like to sort this out. And I think that is in any way a reasonable goal.
One last comment. This is Ralph Drums. I don't know if by a heavy...
Is this personal or with your IAB hat on? I'd like to ask.
Oh, thank you for asking. This is personal. I don't know if this is what you meant by a heavyweight process, but I don't imagine that... I imagine that there are a lot of facets to ICN. We haven't really come up with a layered model for ICN yet. We haven't identified the equivalence of a routing area or a transport area, et cetera, et cetera. But I imagine that's the way work in a working group would go forward. That is, a first working group would take some piece of the ICN architecture, publish a spec for that, while other work continues to go on in the research group.
I'll stop because other people should get on the channel, right? So I think, and I was not involved in DTM, but it feels like it could be that, until 2025, we're not done with the RG. And I think that 15 years since, initiation of this activity is really heavyweight. And that's why I said that there are other people who have done other things much faster and so on. And it may be an issue, as you said, it carving out things that can move forward, that are independent of specifics, IPRs and I don't know what. And we can move forward because you see the room here is full. And there are some pretty significant people in the audience. So why lose the momentum? That's all.
Oh, it's well taken.
Well, I just wanted to request a little clarification on the two options over there, and in particular the second option of proposed above on kind of merging NDN and CDN, and if that's what you're saying, because to me, above should focus on kind of some actual protocol that has some validity in some use case or something, and not trying to hash out differences between two competing proposals just for the sake of hashing out those differences. So this is, I'm kind of a little confused by what this option is over there.
Yeah. Okay, it's a good point. So what we are saying is that at this point we don't even really know what the exact scope of that working group proposal would be. And of course, you would specify a set of functional things you would like to work on.
But finding out what that scope is should be kind of the first step before say, hey, we're going to merge CCN and NDN in some way, and then, or do that in a working group. To me, I'm very confused about the steps here in this process.
Can I say? Yeah, just to respond. Just to respond on that. We just pointed out that these are two possible ways of dealing it. We're not saying which one we think is better or anything like that. It's just, you could do it.
Peter Ashford.
One last conditional clarification. The people who propose the BOF are the people who decide what to put in that BOF proposal. Right? And if the BOF proposal is to say, all this sucks, let's go back to NetInf, somebody might decide to say that. So I think, I don't want to overread what's here, and a bunch of people have talked about it, but I think part of what we're saying is that keeping the part of the discussion which discusses the architectural differences and substantive differences and why they exist and how they might potentially be combined or not combined seemed to us to be right in the sweet spot of what we're already doing in the Icnrg, and keeping that discussion here, I think with the chairs have a general preference for doing that. Whatever the outcome of that is, or anything we get intelligence about from running that process, however it works out, could inform what the outcome of a BOF and what type of working group gets formed in the IETF might be. Is that a fair representation? Yeah. Yeah. So I think it would be the chair's preference here to not move the process of evaluating the architectures and trying to come to deep understanding of the differences and how they might be either kept or sidestepped or resolved is something that the folks who come to the Icnrg are likely to have the skills to do.
Can I add one chair head of personal view on this? So my personal feeling is that we need a waterfall process now to kind of work on a extensive set of requirements before knowing the next steps and so on. So that's, I think, where we have some good knowledge there. I think it's crucial to, like as Dave said, find the sweet spot. So what is the pragmatically useful work we can do? But so I understand there may be different views on that, but that's my view.
Peter Ashford-Smith, Huawei. Could you put up your first slide where you listed out the list of objections or concerns? So maturity, scope, level of consensus, security, IPR concerns, et cetera. And you've spent a bit of time now just focusing on one item, which is potentially two different solutions. I'm not aware of any BOF being rejected or working group being rejected because there were two competing solutions, and have participated in many where there were internal fights between two different solutions. But what about some of these other items? Did you want to discuss some of these others? And the IPR concerns in particular is a big red flag to me.
Okay. Yeah. So to the first point, do you want to?
Yeah, go ahead.
No. So to the first point, of course, it would be possible in a say potential working group to have like competing proposals there and agree on the actual adopted specification and so on. I think this was more a concern as to like the thrust behind such an activity. So do we actually have enough support from the ICN committee at large, and would actually be a successful working group? So that, I think that was the concern that was raised. Regarding IPR, so we did the discussions that have taken place this week haven't discussed this at all. It's something that needs to be kept in mind. It also applies to all sorts of other technologies that are standardized in IETF or are discussed in IRTF. Our view on this, it's probably not so useful to rat hole on this today. So if people can agree on that, we would rather like focus on the, say, agreement that has been developed by the teams, and whether we kind of get some support for these proposed next steps. And whatever we do, the IPR discussion needs to take place at some point.
I just make one comment on this. These reasons for this not happened, like the IPR, for example, was, and many of them were a lot about miscommunication or lack of communication prior and in conjunction with the BOF proposal, that the people at the ISG didn't have the latest and the current information about IPR status, for example, and the security part was also the way it was presented in the BOF and understood was not the way it was intended to say. So a lot of these issues were basis of miscommunication. Of course, they need to be discussed further and so on, but we shouldn't get too hung up on those things at this point in time, because a lot of them I don't think are real stumbling blocks. It can be sorted out just by better communication and discussion.
Ralph Drums again, this time with my IAB hat on and with my gazillion years of experience in the IETF hat on. Actually have two different responses. The first, I'm going to do them in reverse order because I'm hoping I'm going to remember them better that way. Response to what Borje said about the security and the IPR concerns, I think he's absolutely right about a lack of communication. And I'll point out that the minutes from the BOF review, the BOF selection meeting between the IESG and the IAB, we all get together and we make a choice about what BOFs to approve and what BOFs not to approve. The minutes from that meeting are available, and this is the first selection meeting that we've actually made the minutes available from. So if you want to go look to see what the conversation was like, you can go read the minutes and see what was actually going on. I'm sorry, I don't have the link off the top of my head. I think Borje is exactly right that security and IPR concerns were at least partially, if not at least partially, a matter of miscommunication. One of the things that we would need to do here, if anyone goes back for another BOF request, would be to document those things better. When you talk about the IPR concerns may not have been actually communicated correctly to the IAB and the ISG, that might be partially because there was nothing to point at to say, hey, here's what these things are today. So that's a consideration we need to take seriously and make sure that it's well documented. About the maturity scope level of consensus, I think those are sort of indirectly explained by the two competing, I don't want to say competing, the two different approaches we have in front of the ICN today. Again, one of the concerns that was raised was, well, is there really serious interest in moving this technology forward if you're still at the point of having these two different approaches to the technology? And I'll say that I have seen lots of working groups be in a situation where they take two different technologies and try to take them forward. I think the probability of success for those working groups is somewhat lower than other working groups where you've come to that consensus ahead of time, and what you're trying to do in the working group is just document the specification. And I'll say that anecdotally, I guess I was area director for one of those working groups that had two different technologies. We ended up having to flip a coin between the two of them to choose which one we were actually going to publish as the spec coming out of the working group. So it would be better if we could have something that's closer to agreement before we get into the working group. Although, I mean, either way, there's a lot of hard work to do, and it's basically the same kind of work and the same kind of coming to reconciliation between the two approaches. Thanks.
Yeah, I think that was really useful.
Yeah.
Betchen.
Okay, my name is Betchen Sarikaya. Dirk knows me. Yeah. We have a mailing list activity in IETF 5G IP. I'm one of the chairs of that, and then with Dirk van Hugo from Deutsche Telekom, and Dirk Kutcher came to our meetings many times. Now, this is the first time I'm attending this meeting, Icnrg, that I just came to know. And I realized that there is a lot of overlap between what we are doing in 5G IP list and here in Icnrg. So I think that should be addressed, but the best way probably is cross-participation. So if people participate in both, and you can see, oh, this is probably this being discussed there and so on, at least we know what is the status in each group of activities. Now, regarding this ICN working group BOF discussion, if you can take it to the slide 5. Yeah, my suggestion, I don't want to recommend anything, I'm just a simple attendee in IETF. I personally prefer this done in Icnrg. You are officially in RG working group, you can produce RFCs. So why not continue like that and do it over there? And if you want to go for working group, we are also trying to go for working group. So why don't you join us and help us in that activity? Our aim is earliest, I think, next year sometime. I have a lot more to say, but I'm just going to cut short.
Yeah, so we are a bit limited in time. We have to move on. Thank you. We are a bit limited in time. We have to move on.
There's a bunch of people behind you with the mic.
Yeah.
Thank you. Jan.
Jan Seedorf. I just want to mention that, so what I think Dave phrased it well, and you said it, Dirk, I think focusing on the semantics instead of the syntax in the differences of the proposals is very useful and what we should do in Icnrg. I just want to mention that in the Green ICN project, you have to protest. Okay,
It's really difficult for the people in the back to hear anything. Please speak louder. I think Dave or Ryan is a good example. Let's all follow his example.
Okay, thanks. So I start over again. Can you hear me now?
Usually the objections are that I talk too loud.
So
Thank you.
Thanks. I thought you were objecting to what I said. So I just, yeah, okay.
So she had to object that she couldn't hear you.
So I go down. I try to speak louder. So I was saying that focusing on the semantics and the differences more than in the syntax, I think is pretty useful and what we should do in Icnrg. So we had this problem in the Green ICN project where we had two different proposals on the table of underlying technology, what we could use. And one of the problems we had, and I want to mention this, and this makes this whole thing very challenging, is that both options on the table, NDN, CCN, we had at the time are evolving. So at a certain point in time, you look at them, and you think you understand them, and then half a year later, some things have changed. And just to give you an example, I mean, there are 5 or 6 very good ICN survey papers out there. Sometimes if you read one that is just 2 years old, what's in there is already very outdated. All I'm saying is that makes this comparison very challenging. And we had this experience in the Green ICN project comparing NDN and CCN. And each time we thought we understood one, well, one of them had evolved in a certain aspect, being it security, being it, over the wire format, and so forth and so forth. So all I'm saying is it's worth it. It's needed, but it's very difficult because the proposals are evolving. So just keep that in mind. That's what makes it challenging, I think. If they were all finished, finite, it would be much easier to compare them. All I'm saying.
Right,
I don't have a solution. I don't want to complain. Don't get me wrong. I think we should do that, and we need to compare them and more on a semantic level. But it's difficult because they change over time.
Yeah, switching to day for when mode. So I think the idea was really to do this in an agile and also a fast manner. So not to like red hole like for 2 years or something.
That may be a solution to the problem I just mentioned. Do it
Okay.
in a very consolidated effort and not stretch it over 3 years, because then what you decided in the first year is obsolete. Right.
Okay.
Just to comment on that, this is really intended to be a consolidated effort, and hopefully the ultimate goal would be that we would have this effort done by the Kyoto interim meeting, so before September is ended. So that's sort of our wish.
So just to comment back, I understand you're right. Things are evolving. People are. This is Kostas Pedikouis again, Travelpink. Sorry. Yeah, sorry. Lysia is not enforcing. So I totally agree, but this is basically simple version control. In the case of simple version control, so if it's code, you can have a Git identifier. You can have. You can say that I compared NDN April 2014. Well, it is, because if you say that I compare CCN with NDN, you just to say which particular instantiation. So, and things evolve, of course. Just to compare, I was yesterday just listening into an ops meeting, and there was, and now that everybody agreed that we want to use Yang, now we have Yang 1.1, and probably we will have 1.2, and so on. So versioning, that's all.
Right. Mark, do you want to reply to that? No. Okay. No. So, yeah, I think the understanding was that there is a little more to do than just a merging of source code trees, because there are really semantic differences that affect the way that applications, for example, deal with the stack. So that's why. Right, but these are not okay. Okay, thank you.
So I guess I want to make a request for harmonization on some level, because I do feel like, in other cases, we've seen examples where protocols are very different that are trying to address a similar problem. So something like AODV versus OLSR in the MAN-A group, or
PIM dense mode versus PIM sparse mode versus core-based trees. And you can't even really talk about trying to harmonize too much. In this case, seems like these are very similar protocols trying to address very similar issues. And I would hope that we could identify what are some of the key differences and then determine whether or not those differences can both be incorporated with some level of modularity and options and things like that. That would be ideal. And I think it would help with what I perceive anyway as another problem. I would categorize myself as kind of an interested bystander. And there's a lot of them in here, I think. And every time you ask for, who's read the document or who's writing the document, it seems to be a relatively small set of hands. And I think if you could get these two communities together to be kind of working on a common set of documents, that would be a really good thing.
Thank you. That was the idea. Yeah. Thank you.
Vince Park.
Thanks.
Jari, and I'm wearing my ISG member hat, a person who has to look at various BOF proposals now and in the future. And I just wanted to say that you had this list there, the reasons why the BOF was rejected. But I would like to say that it was not so much of a rejection that no, we can't do this because of these reasons, but it's like we need some groundwork done, and we'd like you, the Icnrg, to help us to do that. And so that was basically the request that, okay, let's do those things. Let's have a clear picture in our mind. What are we doing and why? And this is the basis. And the other thing I want to say is that the ICN, it's a fascinating topic. I'm following it quite a bit, and it's important. But it's also a big topic. It has many functional parts. It's evolving. It has alternative designs. So, when we get to, taking some things forward in terms of IETF standardization, we would like to see, a good understanding of what parts are ready for that, why they are ready for that, and what directions among multiple alternatives are the ones that we should focus on. And also have a discussion of, why is it that these particular approaches will gather the community behind them as opposed to being just one of the alternatives. Thank you.
Okay, thank you.
Hi, Mark Moscow, Park. So in regards to the can we actually diff stuff and it keeps changing? I think at the semantic level we can make a lot of very productive progress in looking at the differences and comparing and moving forward at that. I don't see that it's going to be some slippery slope where we can't even agree on what we're comparing. So,
all right.
Ravi, Huawei. So there was one comment saying that there was some first meeting between the CCN and Indian folks to sort out the differences, but I think the first thing is to have the Indian as this kind of Icnrg drafts and have these kind of comparisons more in open discussion, so that it's always a question in everybody's mind, right? We can go into details. I think Mark had one slide that showed the differences, but
are you asking that the result of this comparison analysis be documented in an internet draft, or what?
No. Right now, the only reference for the Indian is going to the Indian site and looking into that. It's not in a draft format. It's not a submission yet, right? So we have the CCN specs, right? So right now we don't have an Indian spec written out. So it's good to basically bring that and start the discussion in the Icnrg working.
Oh yeah, I mean, sure, we have those specifications. The NDN team also has, say, documents that they produced.
Yeah, and what I'm saying is that instead of having it in two different kind of domains, you can bring it to the same forum and discuss it. I mean, I think that would be a good starting point to have the drafts written out, and then we can compare it.
Yeah, so she had off personal opinion. I think it'd be good to have a pragmatic approach and not get stuck into formalisms too much.
Just make them update.
But
again, another question I had was from what Ralph mentioned, security or IPR doesn't seem to be a big issue. Is that what the biggest objection on the level of consensus, that there are these two proposals and they are not harmonized? Was that the biggest issue?
Yeah, we don't want to do this technical discussion now. I think that wouldn't be.
No, I'm just trying to understand where was the major objection from. Minutes. Probably you can send the minutes. Could you send it to the mailing list? Thanks.
Mark Moscow Park. I don't think that saying procedurally we need a comparable NDN spec to move forward is the right thing to do. That just puts a big stop in the process, and I think that, okay. Yeah.
Yes. No, my point is that discussions have to be in this kind of working group, like during the interim meetings and stuff, and not in the background.
So can I jump in with my chair hat here, which is, if we go forward with a design team effort that is going to try and document the differences as a precursor to figuring out which ones we should resolve and how and what the ultimate spec that comes out of that should be. And my expectation as chair is that anybody who would be contributing to that effort as opposed to just monitoring it would be as intimately familiar with the NDN architecture and its protocols and its specs as they are with the CCN ones. And the fact that you have to go read a different set of documents that are hosted on a different site and are in a different format, well, tough, right?
No, the point is that,
you know, that's it.
Yeah, no. The point is that we tend to work with one of the protocols, and mostly when we prototype, we've been using things very based on things like CCN. So NDN has been evolving, and a lot of we hear this because we don't use it in a very practical context. So at least when you discuss it, it's better to discuss it more openly. Just because the point that we don't focus everything that's happening.
Oh yes.
The state of the world today is that the specifications of the architectures, the designs of the two, and the protocols of the two are done in a different way by different groups on different hosting sites, right? That is the state of the world today. If you want to be conversant at a deep level with both of those, I'm just telling you the reality is you'd better go and follow both of them at a sufficiently deep technical level and frequently enough so that you're up to date. And yes, not everybody in the community is going to be able to do that. Hopefully what comes out will be written in such a way that people will understand what we're writing as and suggesting as the output without everybody reading that having to do the same thing, right? I hope we'll be able to, you know, explain things in such a way that you don't have to be an expert in both of those designs in order to understand what we're getting at, right? Okay, I'll let other people
Just
drop
quickly,
in now.
so I can assure you, the whole point of having this discussion here now is essentially to make the community aware and ensure that this is an open process where the outcome of those discussions are shared in an open manner and are also exposed to review in Icnrg. So that's definitely the goal.
Yeah, Mark Moscow Park. I think that we can have very productive conversations about this, even though the specs are written differently and presented differently, and a lot of it is just on the good faith representation of those semantics by the parties concerned, and that's not a problem for me, and I don't think that's not a problem for me moving forward, and I think that can be a very productive mode. But I do agree that the process needs to be open to the community, visible to the community, and that the output, way down the road someplace will be, as it was said, some experimental RFCs, so that the final output will be written, kind of in the manner that you're familiar with like the CCN. Not that those would be the direct basis for anything, but it would hope it would be written as a RFC.
Yeah, thank you.
All right, Nacho Solis, and this time correctly, I'm at LinkedIn. So I want to give a little bit of background on where we are and answer a few of the questions that were brought up earlier. Number one, in terms of versioning, to compare the things, the current work on CCN, you can version by the drafts, which kind of point to a specific spec. In the case of NDN, they have their own spec, which they publish, and you can find on their website, and you can reference things correctly. You don't need the Git checkout, just saying. And the protocols are very similar, given that they both derived from CCN 08 or 07 or whatever thing NDN forked of and whatever CCN 1.0 forked of, which, by the way, I want to say that should have a better name than just CCN 1.0. All right, side note. In terms of history, when Icnrg started, neither Park nor NDN participated in the initial discussions and had documents here at Icnrg. And it was when Mark and I took over that we decided to do our work here in Icnrg in the open, specifically at the beginning just showing our work, and later on submitting our documents to be adopted in the group, to be worked on in the group. NDN has made some presentations, but they have chosen not to submit their documents here at Icnrg. So it's hard to work together here at Icnrg, given that we only have a discussion of things without actually having documents to compare or to choose from. This has brought up an interesting situation. In one of the slides, you brought the IPR issue, which I wouldn't call unclear. Maybe it's not the preferred situation. But I think Park has stated that their IP will be made available on the FRAND for the things that have been submitted, and that has always been cleared. In the case of NDN, because there's no document submitted, there's no statement on IPR, even though it would have the same IPR statement as the Park documents, given that it also uses the same technology and potentially the same patents are involved. So that would burden both of those. And in our joint document, we would be in a similar situation. If there's a joint document, and whenever we get to that joint document, it would be great if we can continue forward, obviously working together and figuring out the best way to have a joint protocol. Whether those experimental documents stay where they are or are eventually moved over to a working group, I'm happy with either solution, as long as we do have the charter to move those forward, and that is what we're doing. Obviously, the charter of Icnrg is not specifically that, but it'd be nice if we as a community work through consensus to do that. Right.
Okay.
I'd like to make 2 clarifications. So I don't know how it works. Right. Can I speak a little louder? Okay.
Before somebody objects.
For one, all NDN documentations, including code and including even bug reports, including whatever the fixes, everything are publicly open online. And whoever we actually welcome every interested party to actually go online and take a look and help. Second is that, yes, we have not brought any NDN related documentation to Icnrg yet. We are running out of breath. But I want to make it one thing very clear. If and when we bring any documentation coming to Icnrg, it will not have the same patent statement as Nacho stated. Okay, we follow the IPR statement that was submitted to NSF back in 2010, which says that the so-called CCN invented at that time, that will be free fall. That's a statement the whole NDN team at that time, including Park, collectively made to the government. I just say that much.
Okay, so I would like to take this as input and cut off any further IPR discussion. Please, we don't have enough time.
I need to reply that I'm not from Park, but even not from Park, I would have to file an IPR statement and saying that the current patents are owned by Park and they still apply.
Yes, but please.
Mark Mosker from Park, just to clarify, I believe in the BOF review, the problem was it wasn't known what the IPR statement was, not that there was a problem with the IPR.
Yeah, there was a statement already.
Yeah, Paul Polakos from Cisco. I just want to go back over, there are a number of topics here, but I just want to make sure that it's clear to everybody in the room that there's strong motivation for going through this convergence effort. And that motivation comes from, not necessarily from inside this community, but from outside this community, from those who are really interested in the technology, but are confused right now about the fact that there are multiple ways of approaching very, very similar solutions. And they're looking to this community to give them guidance on how they should reconcile that. And if we can help that effort by converging this effort, by these efforts, then we'll do ourselves a service and we'll do them a service also.
Okay, thanks. Line is closed after Eve.
Hi. Hi. Hey, I've never been told that you can't hear me, but you can't hear me. Wow. All right, I'm standing really close. Eve Schuler from Intel, and I'm thrilled about this process. Can I suggest, though, having just listened to Leisha and others talk about the legal issues, that in this BOF effort, that we actually have someone with legal expertise come in and inform us or work with both parties, because I don't think us as the kind of the technical side really understands the nuances. So that would be my concern. And as someone at Intel who's watched this unfold, I mean, it's absolutely a huge issue for a company to embrace this or not commercially. I mean, I know that's a long ways off, but it is top of the mind for outsiders or people who want to make use of it without getting into the innards of the algorithms. And that's been our...
So is there still an IAB or an IESG member in the room? Because I want to confirm something. My understanding is that that is not something that we can do, because the IETF's and the Internet Trust's position is that the IETF takes no position on interpreting IPR at all. You state, people disclose it, you state it, and it's up to external things to assess the validity, coverage, and other aspects of IPR.
Can I clarify the ask, though? It's that if you're going to create new documents, that there needs to be some new legal header.
So, yeah, Yari.
I just wanted to confirm that is indeed the case, that the IETF will not, evaluate validity of the IPR or any associated things. Members here or our participants might do that on their own.
Right. So Eva, I mean, I'm sorry, I'm not sure what you want to accomplish. We can do that way. That's all.
Okay. Thank you very much for this discussion and this feedback. So my interpretation is that we got some positive response like to this activity. So this will happen now, and we will later discuss and inform everyone. So what are the logistics for that, and you will hear from that on the mailing list. We're not in a position where we should hum on any next steps regarding working group proposal or anything else. This discussion will continue also based on what we learn from this activity. But I think it's very good that we got some positive response by different people also outside of these camps, if you will. So we are quite enthusiastic with this plan, and I hope you all agree. Kostas, you have 10 seconds.
About the BOF, yeah. The only thing I want to say about the BOF is that I obviously anybody can submit the BOF proposal. What I have seen in other working groups for rechartering and for other kinds of things is that some folks decided to use a more open approach, where there was joint editing of the charter text well before it was submitted. So although anybody can submit a BOF, if the RG decides to move forward, it would be nice if it is a more open process. Okay,
point is we're taking, we will consider all the feedback before we make...
Before we lose everybody, we have one quick wrap-up slide.
Right. So upcoming meetings. So there's going to be the ICN conference in Kyoto end of September. It's going to be an interesting, fascinating event. Thankfully, Panasonic offered to sponsor an Icnrg site meeting on the day after the conference. So we normally do that to engage with like the research community that is normally not attending IETF meetings. So I think it's a good idea. Just have it in mind. And so we are discussing what to do in Seoul. There's very likely going to be a meeting like this again. I think we have something to discuss. Send us feedback whether you think it's a good idea to have an additional full-day site meeting again. So normally we have no problems filling those things, but it should be worthwhile, and consider it's relatively short after the Kyoto meeting. With that, thank you all for coming. See you in Kyoto or Seoul.
People like
Drive. It's good to have this. I'm out for taking a train.
Hey, stay well. See you. Okay.
Take a stop at Bremen. I know. I don't know what I'm stopping, but maybe one of the trains is not working perfectly. A nearby station. You got to Amsterdam. Yeah.